Hey, everybody. It's good to have you here. Thank you so much for joining. If you're jumping in now, we are just about to get started. So thank you. Thank you to everybody joining in. I really appreciate it. My name is David Awad. On the webinar with me is Peter Lee, who's going to be answering your questions in the chat as we go. It should be a good time. I appreciate it. We have a lot to go through today. It should be really fun. We just want to start with a quick poll just to get a sense kind of where people are at. So if you could just type a number between 1 and 3, kind of alluding to your blockchain experience, 1 being not very experienced, 3 being pretty experienced, right? Just kind of rate your level of blockchain knowledge and lay that out in the chat for us so we can have kind of an insight on where you guys are coming from. We'll have another poll at the end as well, but that's just for us so we can understand how to build better content for you guys. So if you could definitely type that into the chat, just a 1 being not experienced in blockchain to a 3 being pretty experienced, just so we can get a good sense of that. Feel free to type that in as we go. So like I said, this is a developer boot camp. So we are going to talk to you guys a little bit about building off of Corda. And to start, we have a whole lot of references for you. So I'd love it if you guys could take a look at these. You could first find people like me and Peter and the other developer evangelists here at R3 on our public Slack channel. You can also find the docs. We've also recently launched a new training site you can find at training.corda.net. You can find our GitHub repository. Corda is open source, of course, so you can find that online at github.com/Corda. If you have any questions about this talk or any other talks we'll be running this month or in the past on our YouTube channel, feel free to send us an email to devrel@r3.com. Lastly, you can find us on Twitter and send us all kinds of fun screenshots and blockchain ideas at Corda Blockchain and at Inside R3 with the usual fun hashtags. So we look forward to hearing from you. So all of that being said, we will start with the agenda. Today, it is going to be a quick recap of the intro to Corda that we did at our last event, if you were there. Then we'll talk a little bit about the key concepts relating to CorDapps. We'll write one together ourselves, and then we'll talk about how to actually run it. It should be a good session, and it should be useful for everyone here, just to kind of build a good understanding of how developers can go to proofs of concept using Corda. So we'll start with the basics, right? To recap from our Corda intro from last time, Corda is a really powerful open source blockchain solution. It gives you strong identity features, it gives you performance and scalability, you have interoperability, you have an open source tool and really easy extensible features to run a network with other people. You have the usual blockchain features of consensus as well as privacy. And you can customize it to get a lot of different levels of these different features to suit your particular use case, which is quite nice. So just to kind of cover the basics here, right? Corda is a permissioned network. It communicates on a peer-to-peer basis and on a need-to-know basis. So let's say you are Titan Technology Partners and someone else is Colorado River Authority. Each of you has your keys, you have your addresses, and you have the ability to communicate with each other and represent digital assets that you're interested in tracking together, knowing with confidence that the blockchain is not going to be manipulated by any of the parties, even if you distrust them. And of course, in any typical Corda network, you have the notary pool operating alongside you to validate the transactions as you go. And we'll talk more about how that works as we get into the flow framework. So just to kind of put this into context, try to keep in mind that our network here between us, Titan Technology, Base, Transcorp, and Colorado River Authority is a subset of the many other Corda nodes across the internet that are working to track all kinds of different assets. You can find out different parties that are using this by looking into the Corda Network Foundation and finding out which other parties out there are really using Corda to track their assets and run notaries to mediate their transactions between each other. Pretty nice. So that being said, let's start with the basics. So we keep using this phrase CorDapp. We're going to have to define it at some point. So CorDapp, long story short, is a Corda decentralized application. So long story short, that means a computer application that runs on a distributed computing system. Not surprising. It is also sometimes referred to as smart contracts. That's another way to kind of refer to what we're able to enable with this, right? So CorDapps are literal binary jars that are stored inside of Corda nodes. Any node can carry multiple CorDapps, and those CorDapps that you write are what enable particular features on those Corda nodes. So we write our CorDapps, and then we copy those jars onto Corda nodes in order for them to have the features that we want them to do, whether that is tracking loans or mortgages or using blockchains for voting or what have you. You can write your CorDapps yourself and then deploy them by copying them over onto the Corda nodes that you have running in your secure network with the other parties you want to work with. So let's jump into this idea of the blockchain at kind of a literal level and see what we can build here. So when we say blockchains, we sort of literally mean data that can be anything you want to represent digitally, anything that you wish to store in Corda. And those states or those things are updated, their representations are updated via transactions that act as the chains between the states of things that we call blocks. For the purposes of this discussion, this is the intuition you should try to use when thinking about this. One of the nice things about having in our model of a blockchain within Corda is that you can also backtrace really easily. All of the transactions exist, and all of these states and previous versions of states also exist. So we even have some nice notary validation features where you can take a transaction and trace the entire history of the chain leading up to that state to ensure its validity, which is quite nice. So it's worth mentioning here, just to keep this in mind, Corda does adopt the unspent transaction output model. So data is never actually deleted from the blockchain or the database. Hence, Corda holds the sort of immutable nature of a distributed ledger technology system. So just to kind of finish this recap and bring it back together, when you're building a distributed app or a CorDapp, Corda provides you some really simple abstractions, right? You have a pretty low learning curve. We support Java and Kotlin and other JVM compatible languages if you're curious. We abstract away the complexity of updating a distributed ledger technology, and we also have some great development tooling. We have a network bootstrapper. We have some really nice tools for Docker on Corda. We have a node explorer that you can take a look at on our blog. And we also have a VS Code extension if you're interested in trying something directly. And lastly, we have some pretty cool developer tools that enable some interesting feature sets, right? So the Corda Settler, I recommend taking a look into, the token SDK, and the account library, which can help you build some more advanced and scalable CorDapps. So just to bring us into the actual live coding that we're going to do today, assuming I haven't talked enough, we're going to build a CorDapp to kind of showcase the issuance of a token. And we'll talk more about what that means. But long story short, the files we need to implement are tokenstate.java, tokencontract.java, and tokenflowinitiator.java. Don't worry if you don't know what any of those mean yet. We're going to break down these different abstractions really quickly before we actually just get right down to building them together. So hopefully we won't lose any of you, and I'll make sure to show you every piece of the process, straight from cloning the repository to running the flows ourselves and seeing the hashes of our transactions. So these are the components of a CorDapp. There are states, there are contracts, and flows. So states are any object in Corda, right? These are cars, these are loans, these are votes, these are mortgages, etc., etc. Any object that is fungible that you want to represent digitally is a state in Corda terminology that you can represent. Corda makes this very easy for you. States get consumed, they get updated, they get stored, they get created, they get destroyed, etc. Separately, contracts you can think of as the tool to verify what you can and cannot do with a state. For example, you can create a car, but you cannot do other actions with a car, right? Maybe if you sell a car to someone, that car must have a license plate of 6 characters, let's say, if you live in New Jersey. Just as a random example, so that 6-character license plate rule might be something you would embed into a contract. So if someone tries to sell the transaction of selling a car to someone else, the contract can verify that the car is valid by ensuring that its license plate has 6 characters. So contracts are the tool or the abstraction we use to validate the operations we can do with states. Lastly is the flows. So when we talk about issuing a token or creating a state, a flow is the tool through which we can trigger updates to the ledger or transaction. So for example, a flow to perform the sale of an object, a flow to perform the issuance of a token, which we're going to do today, and flows to do all kinds of other things like adjusting a loan, making a payment on it, for example, or changing the interest rate, etc. So these are the 3 kind of ideas: the things, what we can do with those things, and then triggering the actual process of performing those things themselves. Putting all of these together, you have a pretty robust set of tooling that you can use to build a wide variety of different use cases on top of Corda. And that's sort of where the power comes in. So I promise we're going to show you some code in a second. This is the last piece of information I want to give you guys, which is the token state itself. The first thing we're going to build, the simplest abstraction for us, hopefully, which is, again, states, the objects we want to represent digitally. They only exist in the participating nodes of the specific transactions. If I sell a car to you, that state exists between the 2 of us. We are the only ones with knowledge of it. And in terms of the code, our state is going to live in tokenstate.java. So that's where we're going to start. Let me close out my PowerPoint here. And I'd like everyone to go online to github.com/corda/bootcamp-cordapp. And I'll give you guys a few seconds to find this link, clone it onto your local machines, and I'll do the same. Peter, if you could drop the link to that in the YouTube chat, that would be great. So I'm going to open up my terminal over here, and I'm just going to clone this repo real quick. So I'm just going to go onto my desktop. There we go. And I'm going to clone the Bootcamp CorDapp. There we go. And I'm going to put it in a folder called 11-6 Bootcamp. There we go. So I will clone that. It's appeared on my repository. So I'm going to go then look inside. You should be on the v4 branch. Just make sure you're on the latest version of that. And you will want to make sure you've just got the right revision. So I'll just run a quick git rev parse head, which will show me the latest version, the latest commit. This is one I actually made pretty recently because we made it a little easier for people to use this when looking at this stuff again yesterday. So assuming everyone's got this, you should have the v4 branch, latest revision, and I will open up my editor just to grab this and import it into IntelliJ. So IntelliJ is going to be my editor of choice. You are also more than welcome to use the Corda Online IDE. I believe that is at ide.corda.net. I'll actually double check that real quick. Yep. You can try any of those online tools and find links to them. Hopefully Peter is dropping them for you in the chat as far as the online IDE is concerned. So if you're using IntelliJ with us, you'll get to see all the specifics. So for us, we cloned this onto the desktop, so we're just going to open the project in IntelliJ. We're not going to import it because that blows away some of the project configuration. So I'm going to hit open here and just jump onto my desktop. 11.6. I'm going to hit open there. And we are loading the 11-6-bootcamp project. So you'll see here that IntelliJ is going to ask me if I want to import this Gradle project. I'm going to do so real quick. There we are. We're going to do a few other quick project-specific configurations before we get started with actually coding. First, looks like we have our first error, which is good. Now this one is going to be complaining because I've got to do a few things for my own editor. If you're on Mac, you may run into some issues with Java 1.8. So just make sure to click this little elephant on the right side and double check that your project's Gradle JVM is set to 1.8. Hit OK. Rebuild your project. I'm going to do one other thing, which is go into the project structure settings. You can find this by hitting Command semicolon or going into File, Project Structure, and specify the SDK. In this case, I'm going to go for Java 1.8 and specify the project language level of Java 8. So again, that's the project SDK 1.8 and project language level, and set that to 8 as well. So I'm going to hit Apply and OK. Gradle is probably going to need me to rebuild, which is fine by me. Go. Let's see. All right. Configure successful. Green check marks. Looks good. So I'll give you guys a few minutes or a few seconds just to make sure that is all set up. Remember, that's just to go into the settings here. You can find these settings by hitting the Gradle box over there, hit the wrench, and then you will see this Gradle JVM version. And again, that is project structure for the Java 1.8 settings I was looking at before. If you've imported successfully, you should see a few things in here, a few modules that we're going to be working out of. So I want to just kind of outline those for you now. So inside of the Bootcamp CorDapp, we have source, main, Java, Bootcamp, and we have 4 files: token contract, token flow initiator, token issue flow responder, which we will talk about when we start looking at flows, token state, and of course, contract tests, flow tests, and state tests. So for us to start off, we're going to look at state tests, and we're going to look at the token state file itself. Hopefully you guys have got this open. And so since we're good test-driven developers here at R3, we are going to talk a little bit about what these files, or what these tests actually do. So we have this idea of a token that we want to represent visually, right? And we talked a little bit about, let me pull this back over. We talked a little bit about how we want to have the idea of a token state that implements the Corda contract state abstraction. And we want to outline the issuer, the owner, and the amount. It's like I need to zoom in to make this a little easier. All right. I don't know if I can zoom in. Let's see if I can get that. Yeah, hopefully you guys can see this. It might be might be a little tricky to get this to zoom in, so hopefully that's not too big of a problem. All right. So, like I was describing, we want to build a token state that implements the Corda contract state interface. We will outline a few properties: the party issuer, party owner, and the amount itself. So let's get right down to it. So inside of here, we have some tests that are just going to verify some of the assumptions we're describing, right? We have, we want to make sure that our token state has the correct issuer, owner, amount params, and those kinds of things. So we'll start by creating a token state in our tests. Then we'll assert that Alice is the issuer, that Bob is the owner, and that the amount is 1, because we've instantiated that here. We do a similar thing with the participants, and we make sure that the token state implements the contract state, like we were describing. Of course, all of this is going to be red because we have not implemented any of it. So here we are inside of the token state. Again, this file is inside of Bootcamp, source, main, Java, Bootcamp, token state. So there's a few things we're going to do here. I'm just going to run over to a set of notes I have over here. So to start, we want to point out the fact that this is going to belong to the token contract. Every state has an associated token contract class. We're going to be implementing that in a little bit. So our state tests won't pass just yet. So just be aware that our token state, again, is going to implement the Corda contract state. abstraction. And then within here, we're going to create a few member variables. We're going to create some parties. We're going to start with the issuer. Then we're going to have the owner. Then we're going to have the amount for the token. Then we are going to have a list of type abstract party. And we are going to call that participants. Whoops, there we go. So we created our instance variables, and we will probably continue to get complaints for a little bit longer as we implement this. So let's just start by creating the token state class itself. So public token state, party issuer, party owner, amount. Go. Looks good. So we're going to do this dot issuer equals issuer. This dot owner, just the basics. This dot amount equals amount. There's a really nice keyboard shortcut to do this, and unfortunately I did not remember it. So we're just gonna have to go the hard way here. So we'll create a new array list to store our participants, and then we're going to add the actual owner and issuer into this array list of participants. And this will come in handy in the future when we start looking at some other pieces of this process. So for now, just make sure to add the owner and issuer to the participants list. And it doesn't matter too much the order you add these in, but I will go issuer first, then owner second. That's pretty much everything for this method. Then we're just going to add some getters. Simple enough. Then I'm going to do the same for the owner. Go. I'm going to do one more for the amount.
Hey David, really quick. So when you get a chance, do you mind to zoom in a little bit? So from the preference, and then we can see the editors, and then font.
Thank you. Yeah, let me go. Let me try 16, see how that looks. Does that work for people?
Thank you.
Is this clear? Cool, thanks. Appreciate it. All right. So, as I was saying, so we want to implement that last getter, public int get amount, and then we will return amount. We actually don't need the this dot. That looks a little more verbose than we want. All right. Lastly, then we're going to add one more method, which is just to return that list of participants we created before. So we're going to go at override at not no public list abstract party get participants, and of course this is just going to return participants. Here we go. Hopefully your class looks something like this, if everyone can see this. I'll give you guys a few seconds just to make sure you've got all that down. I know it's a lot. So again, the big talking points here are that we provide a contract state class which you can implement the methods of. And so we have a few kind of tools that provides you, and that's why that interface defines this method here for getting the participants, which we track in most Corda in most Corda state classes, and that's what this notion of owner and amount being the participants is all about. So whenever you're writing a Corda state, make sure that you implement the contract state abstraction, and make sure you specify what contract is actually associated the state that you're writing. Now we can't run these state tests just yet, as we have to implement contracts. But hopefully after we've run contracts, our tests will all run right out of the box. Hopefully. I don't know of any demo that's ever worked on the first try, but we'll see what we can do. So, assuming everyone's got this, I'm just going to move on and jump back into the slides for a little bit here. Talk a little more about what the contract is doing relative to the states or objects themselves. Hopefully we can see this. All right. So again, we talked about those. Contract states being, those regular states being the object, and the contract states are the rules that outline what makes transactions valid or invalid. So to make this a little more clear, right? Every transaction or ledger update is done via a contract verifying the validity of it. So in the ideal case, you have some input state. Let's say it is a loan, and that input state of the loan has some amount on it that is due, and that previous version of the loan, when a payment is made, must be updated. And so a transaction happens that consumes that existing state and then performs a transaction on it, consuming the input state and producing a desired output state, right? According to certain contract rules. So those rules obviously need to be followed during a transaction. So try to keep that in mind when thinking about this, right? A transaction is only valid if all of the contract rules have been properly fulfilled. So if our contract says everything is good and we have these beautiful green check marks, then we get a ledger update that is recorded to all of the parties involved. And of course, on the other side of this, if one of the rules does not pass, the ledger update is rejected. And that's pretty much everything to keep in mind. One other note, in terms of input states, there is not always an input state. In our case, we are creating something or issuing a new object. And so the token state we are creating will not consume an input state. We're just doing this for simplicity as far as showing our proof of concept here. But it's worth keeping in mind, of course, that the majority of use cases probably do consume an input state. And we have plenty of samples online on how you can do that. You can also contact us after to get some specific links if you have specific questions. So this is an issuance transaction that we're about to write. And so our contract code is going to look something like this. Now, in this case, the token contract Java class implements the contract abstraction that we also provide for you. So we're going to implement a verify method that takes a ledger transaction and verifies a few important properties of it. One, that there's no input states, like we were describing here. Two, that there's only one output state, right? We are only issuing a single state, and that output should be of type token state. The issuer should be a required signer for the transaction to be valid. The owner must also be a required signer, and we'll make sure that the amount field is positive because you can't issue negative money, just as a good kind of rule of thumb and a nice rule to add on to that. So let me dip on the slides real quick. So I'm going to pull up to start with the contract test, just to kind of outline. We talked a lot about 6 very specific conditions here. So there's actually a lot of different ways that this can go, that this can be tested, right? There's a lot of different moving parts to this contract validity. So we have a whole lot of state tests that I recommend taking a look at inside of here to see how we you might want to think about testing this. For example, the intuitive first test case require that the contract has 0 inputs, to the transaction. Require that the contract has 1 output, require that the contract has 1 command, etc., etc. So definitely take a look at the contract test. We will run these in a little bit to make sure that they work the way we expect. But I just wanted to give you guys a good sense of how thoroughly you can test and validate the transactions that go through these fungible assets that you want to represent. So jumping out onto the other side, looking at token contract. Token contract.java is the next file we're going to look at, also inside of main Java Bootcamp. So you'll see here we have a bit of a few method skeletons here that are worth talking about. So the first thing worth mentioning is that, again, token contract implements the contract abstraction. So that's the first thing to be aware of, right? This contract abstraction needs to exist. And if you have this little red blurb inside of your editor when you're trying to add this, just remember that sometimes IntelliJ needs a few extra imports. You can hit Alt-Enter to add it. So in my case, I will do so. It should be included right in the imports up there. So the token contract that we are going to write implements the Corda contract abstraction. We're going to leave this ID intact, and we're going to override the method transaction. Go. We're going to override that verify method. Now we can see here how it takes a ledger transaction, and it also throws illegal argument exception. Now before we start writing this, I want to speak a little bit to the commands interface that we have down here. So contract commands you can sort of think of as the actions themselves that we can do with those objects. And so you'll see here that we have kind of a skeleton class called issue, which makes sense. Now issue here is purely a convention. We could call this whatever we wanted. We are defining our own semantics for how we want to name our commands and what those commands actually mean within the contract code itself. So in our case, we are using the word issue, but that is purely a semantic distinction for our simplicity. So you can create other commands such as sell or sell to state, sell to government, sell to private citizen, etc. And you can create those different commands that have different types of verification that you would apply. So in our case, right, we are just going to retrieve that command and put a conditional statement around what kind of command this transaction is trying to perform, so that we can write the correct verification for that transaction. Hopefully, all that makes sense. Feel free to drop again questions in the chat for Peter if you need anything on that, and feel free to let him know if he needs to stop me for anything else. All right, so I'm going to start just by getting a command with parties object of type token contract.command. Whoops. And we're just going to call this command. This is actually the commands that we are receiving in the transaction itself. And we'll talk more about how the command gets specified when we look at the flows. So we're going to get the commands from the transaction and then retrieve them here and use them as a variable. Token contract commands class. So we're going to create a command with parties object. And again, that is require single command tx.getCommands, token contract.commands, class being the other argument, and of course the semicolon. So let's start by creating some lists of contract states. We're going to create two lists. These are the inputs and the outputs to the transaction. So I will create those right here. List contract state inputs equals tx get input states. Go. I'm going to do an alt enter just to get that imported as well. Then we'll do the same thing for outputs. And of course, if we're going to get output states, we need to change this method as well. Cool. So now we've got the inputs and outputs to our transaction. That sounds like it's going to help out. So now we want to write validations that are specific to the kind of command we're interested in. So in this case, we're going to go and look if the value of the command is an instance of token contract dot commands issue. And this again is just the issue that we've defined down here. So we have our if block. We're going to do one other thing. If we currently have only defined one command, we've only defined the issue command. So if we get a command to this contract that is not issued, we're just going to throw an exception for now. We're going to throw a new illegal argument exception that just says, hey, unrecognized, whoops. we're just going to throw an exception that says, hey, unrecognized. There we go. Awesome. So now we're prepared to actually write all of the verifications that we were talking about. We've specified within this transaction of our contract code of this command type, we want to validate 6 rules, right? We want to validate just looking for these 6 rules here, these 6 things. I'll drop them in here. Oops. There we go. We want to validate these 6 things. That there's no inputs, that there's one output, the output is a token state, the issuer is a required signer, the owner must also be a required signer, and that the owner's amount field is positive. So let's start with the easiest one, ensuring that there are no inputs to the transaction. So we are going to add a function here that is a require that, and it will do most of our stuff inside of here. So we will start with require that, rec, and we'll use a quick bit of function magic here for those of you who like that. Fix my horrible indentation here. There we go. We're going to require that the transaction must have no input states. And of course, then we have to pass the actual conditional for this to be valid. And that will be, in this case, inputs dot is empty, right? Which makes sense. There's no inputs to the transaction. On the other side of it, we want to make sure that the transaction has a single output state. So we're going to do output dot size 1. Great. Then lastly, we are going to, or then next, we're going to make sure the output is a token state. Transaction output must be a token state. So we're going to specify that with another conditional. This one's also pretty simple. In order to get the actual, in order to get the actual token state or the state from this transaction itself, we're going to call outputs.getZero. And then we will make sure that this is an instance of token state. There we go. Cool. So now we're going to do one other thing. We're actually going to stuff that into a variable so we can use it for some other things. So we're going to call token state. I'm going to create a token state that we can use here. We're just going to call it output equals, and we're going to cast this. We're going to cast this outputs.getZero to type token state. So now we have the same token state that we were using before. No difference there. And with this output, we can validate some of the specific aspects of it. So for example, we want to make sure the next thing on our list that an issuer is a required signer. So let's do that. The reason I'm adding these descriptions to the requirements is actually because when you run your contract, these will be the error messages that get produced if contract verification fails for one reason or another, which can be nice when you're trying to troubleshoot or audit your transactions after the fact. So the issuer must be a required signer, so I'm going to pass a conditional here to get that required signer and make sure that its owning key is legitimate. So we're going to call commands.getSigner.contains, and we're going to make sure here that the contained in the list of signers is the owning key of the issuer. So I'm going to call output.getOwner.getOwningKey. And we'll see here that we are validating that the correct key is within that list. And then we'll do the same thing, not for the issuer, but for the owner, who also must be a required signer, which makes sense. Whoops, made a small mistake here. I called output.getIssuer.getOwningKey. And here I'm calling getOwner. Sweet. All right, there we go. So then on the other side, we are going to add our last condition, which is going to be to make sure not just that the issuer and the owner are required signers, but that the amount field is positive. And so we can actually do this one relatively easily. I'm going to add one more conditional here, which is that the amount must be. Like that, we will go and call. In this case, we already have the object, so we can just use that getter we called before. And we will specify that this is greater than 0. And that looks like it should be it, with the exception of the fact that, of course, this function has to return something. In this case, if it returns null successfully, then the verification has passed. So it would seem, if we're lucky, we've written everything we need so that these tests work on the first time. You can feel free to paste your bet in the chat whether the tests will work or not, depending on how confident you are in my ability to write code. Frankly, I give it about a 50-50 if this works. So I'm going to rebuild the Gradle project real quick, and I'm going to open back up the contract tests, and we'll see if they work. So I'm just going to hit this nice little run button. It should run the entire suite of unit tests we have here, and then we will see. So everyone cross your fingers. Yes, this is another detail worth mentioning. So if you're running this in IntelliJ, you may run into one other little painful thing, which is just the module class path can get a little bit bungled. So specify that JRE and also specify the class path. In this case, it's, I believe we can just set it to 11-6 bootcamp, and we shouldn't have any problems there. So I think it's test. Let's see how that works. All right, it's running. Now these tests might take a little while. There's our first check mark. That's good stuff. Check, check, check. I'm blown away. So this is nice because it verifies a few things, not just that our contracts are valid, that our state tests are also valid. We have some warnings here just from some Corda compatibility things, but you won't have to worry about that too much. Next thing I want to try running, just to make myself feel good, is the state tests. So feel free to take a look at those. Same story. We're just going to hit run state tests over here in IntelliJ. We'll have the same situation with the modules. So we will run the tests, and the JRE should still be set to 1.8. Apply that. Run these. See if it works. Great. And it passed instantly. This is good stuff. So the last piece to talk about is, of course, the flows, and we will get into that in a minute. Feel free to open flow test if you want to prepare. But for right now, I'm going to jump back into the slides and talk a little bit more about what's happening when we really run flows. So now that we've written our contract, we've written the rules that outline what we can do with the objects we want to represent and what makes those commands or what makes those things we can do valid as outlined by the contract. We now want to think about how we can actually trigger this whole process. How can we trigger transactions? How can we include our own custom business logic into this process so that we can trigger the contract updates to the state when we want to? And this is where flows really come in. So take a minute to just kind of absorb this diagram and think about what a flow is. A flow, we like to say it executes the business logic, but really a flow is a way for you to trigger transaction updates. So flows have a few things going on. They consist of two classes, an initiator and a responder. The idea here is that if I'm going to trigger a transaction with you, the two of us, obviously, if we're going to have a conversation, one of us has to start it. One of us has to say, hey, I'd like to sell you something, or I am going to sell you something, sign this contract, right? There is this idea that one party initiates a transaction and other parties respond. Now, this is not a one-to-one relationship. There can be one initiator and many responders, etc. There's more on that in the documentation if you are interested. But for our purposes, imagine a party A and a party B enter the notary pool, like we talked about earlier. where A proposes an update of some kind. A says, hey, I'd like to sell you this car, or I'd like to issue this token, this loan, this amount of cash, what have you. So I'm going to propose this update. I'm going to run my own contract code against my own update for this CorDapp that I have installed on my node, my Corda node. You have the same CorDapp on your Corda node. So when I propose and validate and sign my own update, I will send that to you, the other party, who will receive it, and the responding flow will be what retrieves this information and be triggered when my initiating flow communicates with you for a signature. So my initiating flow will do these three things. Then I will communicate with you. My Corda node will communicate with your Corda node, running the same Corda code, and respond to that flow. It will check the update, and by check here, we mean the contract code, right? Our second signature here will come next. If the contract update is valid, we will then sign it ourselves as party B. Then party B will inform party A of its signature to the contract, at which point party A will go back to the notaries and ask the notaries to sign the update as well. If the notaries sign the update and it is considered valid, these can also run the contract code that is configurable depending on use case. Then the update can be recorded for party A, and then party A will inform party B, and party B will have the recorded update as well. And so what you are seeing in this timeline is the life cycle of a flow. And what you are seeing as well is the life cycle from the perspective of A, the A being the initiating flow, and B being the responding flow. So this kind of makes sense, right? I go to you, I want to perform a ledger update, so I have to do a little more of the paperwork to make sure it happens. But you have to obviously sign it before we can go to a notary to ensure that it to have it validated, and then both of us update our checkbooks. Is kind of the idea here. So hopefully all that makes sense. If you have questions, feel free to drop them in the chat as we go. So we're going to implement a very similar scheme to this. I'll jump out of the slides for a second and jump back into the flow tests, because as always, we're good test-driven developers, so we want to actually make sure that we're using tests. Now, it may not surprise you, there's a good chunk of tests here, because there's a pretty important series of steps that we want to make sure we can perform correctly. So I'll start by uncommenting all these tests. Do that right here. All right, so we've got our tests, and just to kind of keep up the theme here, the tests here are similar to what we've been describing earlier. How is the transaction constructed? Is it constructed by the correct notary? Are the correct amounts being created on the other side? We see that here, asserting that the amounts are equal to 99, and that the output states that there's one output state, etc. We have some other things about the correct contracts and things like that. So definitely take some time to look over these unit tests if you get a chance. So let's go back and open the token flow initiator. And before we start writing this, I want to do a little bit of lip service to the token flow, the token issue flow responder as well. We're not going to implement this ourselves. Most of the time, you can use Corda subflows to accomplish the job of responding in most use cases. So just to outline the framework here, inside of token flow initiator, the first thing that we actually specify is not just the initiator, but who is going to respond to this. Am I an initiating flow? So that's what's happening here underneath these imports. We specify that this is an initiating flow class, and that it is startable by RPC, and that this token flow initiator extends the flow logic class in Java, or sorry, the flow logic interface. And so we define some other things that the flow needs in order to run, which is the owner and the amount. The issuer, it is assumed here that the issuer is going to be the node that runs this. If I'm issuing a token to you, then I don't need to know myself. I only need to know who I am issuing to. And so when we see this token flow initiator class, we see that inside of the token issue flow responder, that this class is explicitly identified as the initiating flow. And so on the other nodes, when I run my flow and tell other people that I'm initiating a token issue flow, those guys know how to respond to that because of this code that we were talking about. And right now, all we really need to do here is we can actually just use subflows, right? We can use the subflow provided to by Corda to receive a finality flow from the quote unquote other side and submit the signed transaction ID. And pretty much this does a lot of the heavy lifting for us. And the last thing I want to mention about this is that when we have this signed transaction, we can actually implement our own custom checks on the responder side here as well. It is not, the contract is not the only place for you to enforce certain conditions. You have a lot of different places you can do them. So it's not just that any random person who proposes to a signed contract update can do whatever they want. You can ensure certain boundaries on that as well. So that's pretty much everything I wanted to say on the token issue flow responder. So feel free to close that and keep it open if you like, but most of what we're going to do is in here. So we leave a couple of to-dos inside of the Bootcamp CorDapp, inside of this file. To do 1, 3, and 2 here, I just want to specify that we've actually done this in the correct order, even though the numbers are in a different order. It all depends on the way different people at R3 like to present this. So in our case, we've implemented token state, which is our step 1, and we've also implemented token contract, which is our step 2, which is how we end up at step 3, which is to build our token issuance transaction update. So just to outline what's happening in this code a little bit more clearly. When I run a flow, if I'm going to issue currency to somebody else, again, just to reiterate, I am not the owner, I am the issuer issuing this currency to somebody else. So I need to know who that person is in order for, and I also need to know how much the amount is that I'm issuing to them. This is why in our token flow initiator, this is all that the flow needs to know in order for it to satisfy its own abstraction. We create something called a progress tracker, and this essentially will show you command line visibility within the Corda shell of the progress of a flow as it is running. And you'll see what we're talking about a little bit later. But this is a very nice little tool that you can use to observe your flows as they're running and get some sense of which steps within the flows they're actually at. So now let's talk about the meat of this class and where you'll probably spend most of your time if you're writing CorDapps, which is inside of the call method. So as usual, we're overriding the interface here. This is also suspendable. And when we say suspendable here, what we mean is that flows obviously are mediating the connection between you and somebody else. So we need to make sure that these can be suspended. There is a great blog post by one of my colleagues named Sneha on the Flow Hospital that I highly recommend taking a look at after this. So when we call this signed transaction, what we are doing is this is the code you can think of as actually running the flow. And so the first thing that happens is we choose our notary. We actually go and we ask the Corda Service Hub to give us a reference to the network map cache, and we get the notary identities, and we just grab one. We grab the first one we find, and then we get our own identity so we can use it as we are the issuer. And so then the next thing we can do is actually create the token state class so that we can start really building something more meaningful here. So the token state, you can probably intuit, is going to be created using these private member variables that we created before. When the flow was run, we passed in the owner and the amount, and we passed these in from the command line when we actually trigger the flow. So this token state is just going to use those, right? So we are going to say new token state issuer owner transaction, whoops, amount, getting these terms overloaded here. So we've created our token state. Now we need to build a transaction. So unsurprisingly, we have a transaction builder abstraction. So we will actually take the notary and pass that to the transaction builder to get this process started. So we have the notary that we're going to use. The next thing that we're going to do is actually verify our transaction. Actually, there's one other thing a few other things I need to do before we can get to transaction builder.verify. Sorry about that, guys. So before I can actually verify this transaction, we need to specify one, what kind of transaction is it, right? So that is where the command data comes in. Whoops. Go. So we're going to specify our command data, and this is going to be the issue that we were talking about before. So you'll see here, we're going to actually go and specify the token contract.commands.issue, which makes sense. We are creating an issue transaction, so we have to specify this command. The next thing we're going to do is we're going to add the command to the transaction. So we're going to call transaction builder.add command. We're going to add the command data, and we're going to add the issuer's owning key. Then we're going to add the owner's owning key. And just for being thorough here, this next piece of the transaction builder is going to be adding the output state, which makes sense, right? We have some tests around this. So we want to make sure that our output state is only one token state, a modified one. And we're going to pass the token contract.id. All right, so we've done a lot of grinding, built out the details of our transaction. We know what type of transaction it is. And we have the actual details of the states that we want to be exchanged here. So now we can go and call transaction builder.verify using the service hub to get Corda to get our nodes to do this, right? So then after that, we have our flow session. We're going to initiate a flow from the perspective of the owner. We create a signed transaction. And then not only do we sign it ourselves, but we make sure that we have others sign it as well. In this case, the others signing it are obviously the other parties. So once the transaction is fully notarized, it will be recorded automatically by the platform. So you might notice, like I was describing earlier, you might expect there to be a lot more code around these other ideas we were talking about, right? This idea of going to the other node, waiting for them to respond, dealing with network latency, peer-to-peer communication, network bandwidth problems, etc. So Corda handles all of this for you, which is really nice. And so that's what these subflows are kind of doing for you. And I highly recommend kind of digging into the docs to see the specifics of what these do. Fortunately, most of the time, you probably won't need to worry about these much because they're pretty sweet abstractions. So these subflows do things like, as you can see here, collecting signatures, or the finality flow, which you'll see a lot, which, for lack of a better name, right, it finalizes the transaction for you. Once you've got the fully signed transaction, you can basically take this and run with it. So let's run our flow tests. Hopefully this all works. We will see what happens, that's for sure. So here we are back in flow tests. You should be able to just hit the run button, and I'm going to click run flow tests right here out of IntelliJ. We will probably get those module problems. Yep. So I'm going to specify here the Java version 1.8, and we're going to specify the test module within the bootcamp. I'm going to hit apply, and then I'm going to hit run. And let's see what happens. The flow tests may take a little bit longer because we create a mock network with party nodes that are intended to sort of replicate all of the aspects of the network, which can be really nice. Most of the time, just as a pro tip, if you're going to be working on CorDapps, I recommend actually running your tests and writing very thorough tests with various different scenarios and running them from here, just because it can be kind of a pain to open the Corda, to rebuild your node configurations every time, open the Corda shell, and then run the flow directly. So this can be a much nicer way to do it. This looks good. Wow. Can't believe it worked. Awesome. Okay. So now this is kind of the last piece of the puzzle. I've shown you a whole lot of editors. I've shown you a whole lot of abstractions. I now want to show you guys how to actually run this flow. Peter gave me some good advice earlier. I'm going to zoom this in. Hopefully this is clear enough for you guys. So again, I'm just inside of the bootcamp directory. I'm going to clear this out, and I'm going to start by running I'm going to call the Gradle wrapper. If you do an ls-la in here, you will see this Gradle W executable. Some people say Gradle U. So I'm going to start by running Gradle W/deploy nodes. And to understand a little bit more about what this is before I run it, I will run this task. And what this is going to do is it's going to build our actual node configuration. It's going to handle a lot of the kind of lower level tasks of figuring out how the nodes are going to talk to each other, creating some of the certificates and a lot of information on the actual party that exists. And so all of this is defined inside of this top level build.gradle. So you'll see here, I'm actually running the deploy nodes task. It does a few things, right? It checks the Java version. It outlines, these are the different nodes that we want to create, right? So leave that in the background for a second. So it outlines 3 different parties, right? Parties A, B, and C, as well as the notary. It also outlines passwords for the user accounts on the Corda shells of each of these nodes. This is really nice because obviously when you're testing, you can do a lot of experimentation with these kinds of things. Change up passwords, change up the permissions of which nodes can talk to each other so that you can get a really good idea of how you can expect your CorDapp to perform in production when running on a real Corda node. We also have some other information in the build.gradle worth taking a look at for where the sources of all this software comes from. And of course, the Corda release versions and some of the other plugins that we use that are also available online. You can kind of see where those come from. Probably, though, I suspect the majority of your work will be around this kind of node configuration tooling. So to come back to the terminal here, it looks like our build was successful, equally shocking. So I'm going to take this and just do a quick, just for my own machine, I'm just going to make sure I don't have any other Java processes running. And then I'm going to run the ./build/nodes/run nodes. So what this is going to do is it is actually an executable that has been created for us by the cord form task that we just ran, that being this one from the deploy nodes Gradle task. So this is going to actually run our nodes, and it should run them correctly on your native local machine, whether you're on Mac, Windows, etc. So let's give it a try. And if this works correctly, we should see my terminal over here pop up with a few different processes. And let me see if I can zoom this in just to make it a little clearer for people. Looks good. All right. How's that look for people? I'm hoping Peter will just let me know if this is hard to see, but if it is, just feel free to post in the chat really quickly. Go. All right. There's a lot of text on the screen right now. Let me just do this just to make it super clear what's happening. So we have a few nodes here. We have party C, the notary. I'll just start with party C and run it towards party B. This is the typical Corda shell. You'll see a few things that were outlined in that config file: the peer-to-peer messaging address, the RPC connection, localhost, and these actually come from that task as well. You'll see here that the RPC settings are outlined the ports and things for the different nodes. So party A, party B, 1007, 1008. In 2010, 2011. That's what's kind of happening here. So I'll just take party up. Okay, well, party C is already minimized. Then I'll start with party B. And what I'm going to do is actually just run the flow start bootcamp token flow initiator. Actually, before I even do that, just to show you guys what this kind of looks like, I'm going to run a quick flow list. This shows all of the flows that this Corda node has available to it. And we'll see actually that there is the bootcamp.token issue flow initiator that we were talking about. And so one other nice thing to notice here is if I go and I run flow start bootcamp, let me just copy it. So if I go and I run flow start bootcamp token flow initiator, you might be wondering what's the format, or maybe you'll forget because there's a lot of different paradigm submitting arguments. You'll actually get a nice little hand guide here for running the actual flow. So in this case, like we defined within the flow, this owner party amount int actually comes from inside the token flow initiator, inside of the class definition. This party owner incident, where that comes from. So as party B, from the perspective of party B, I will specify that the owner, the person I'm going to issue this to, is going to be party C, and the amount is going to be 33, let's say. What the heck? Very well, parsing flow. Oh, here I am talking about how nice the user experience is, and I mess it up. Owner party C amounts 33. Hopefully that gets us there. So here we see the progress tracker actually running, and we didn't add too many things to it, but we see the basics, which is it starts, it requests a signature by a notary service, it validates the response, it broadcasts the transaction to all the participants, and it's done. And the flow is completed with the result, signed transaction, and it shows you the ID, which is quite nice. So this is kind of the whole sort of life cycle of building a CorDapp, getting yourself from an idea, from this abstraction of a thing that exists in your mind, to an article that you can track digitally using a blockchain that is totally immutable. It's a really powerful little thing, and it's a great set of tooling that you have available to you. One thing that you may want to find inside of the actual README for this project, you will see all of the abstractions we talked about, as well as some other tools to run this flow and other ones, and get some nice things out of that. There's one last thing I want to show you, which is a vault query. Now, we didn't talk much about this notion of the vault, so I want to just talk to it briefly. So here within Party C, right, we talked about this idea that the two of us manage states internally. And one thing about that is those facts or shared states or things are stored inside of a vault. So we ran the issuance from Party B. And one thing I just want to show you guys is how you can actually run a vault query, meaning how can I be sure that when this flow was run, that Party C really has it on the other side the way we expect. So we can actually do that. We can run something called a vault query, where again, a vault is just what we refer to as the private store on a particular Corda node of the facts relevant to that particular party. So in this case, I can go and do this. I can run a Corda query or a vault query to the vault. And you'll see this also in the bottom of the README. So what I'm doing is I'm specifying that I want to run a vault query, and I'm specifying the contract state type, and I'm calling it I'm passing that bootcamp.token state, which is our state familiar. And there we go. So we see that the issuer is Party B, that the owner is Party C, and the amount is 33. Hey! So there you go. We also outline the type of the contract. We have the notary that particularly signed it. We have some different aspects of the transaction that is really thorough, and it's quite nice. So I highly recommend trying it for yourself, going through this process. Hopefully all of this kind of made sense. It's a really robust system that does a lot for you. And we love to kind of talk to people about the different ways you can use Corda to enforce smart contracts between you and other businesses or other parties that are mutually distrusting, which is quite powerful. So I'll jump back into the slides just to talk to you guys about a few more quick things, and we can probably give you some time back. So we've seen all of this happen in action. We've seen it run within the terminal, and yeah, we hope that this was meaningful for you guys, and that you might be interested in the following workshops on how you can extrapolate this further, to use accounts on your Corda nodes, and to use the token SDK. Those will be run by my awesome colleagues on the DevRel team. So I highly recommend that. We will run them multiple times each day in multiple time zones. So we'll make it really easy for you guys to find us. And once again, highly recommend checking out our new developer training site. We've worked really hard on it, and it's a great resource for people who are interested in learning or kind of trying to digest a lot of the concepts we may have blazed over here pretty quickly. So hopefully you take a second to look at that. If you have any questions about this bootcamp or other ones, as always, you can reach us on slack.corda.net. You can check out the docs on docs.corda.net. Our GitHub repository, as always, Corda is open source from the start. You can contact me and my other team members at R3 using the email devrel@r3.com. You can find us on Twitter, at Corda Blockchain, at inside_R3, and then take a look at the hashtags, hashtag Corda and hashtag R3. So I believe that is everything that I have for you. So thank you very much. Check us out on LinkedIn, on Twitter, on the various social medias. We're always happy to talk to people, and you can find us in lots of different ways, and we're always looking for new ways to talk to people. So I want to thank you for taking the time to do this, and appreciate it. Yeah. So one last.
David, yeah, let's close with a poll with the
Yes.
audience. Yeah. Yes.
Yes,
Go ahead.
thank you, thank you. So I had just remembered that as well. So we have one more poll we want to get from you guys just to see, how are you thinking about Corda and blockchain? Are you doing this as part of a professional capacity to get a better sense of how you can use Corda for particular services and industry, or are you just learning? Comment a capital P if you're using this for professional purposes, or if you're just here to learn with us. Comment a capital L. So thank you, Peter, for the catch. Yeah, please do let us know if you're here for professional reasons with a P, or just to kind of learn along with us with an L. And with that, I think that is everything. So once again, we appreciated your time. I believe we ended up a little shorter than we needed, or than we were expecting. So hopefully we've given you guys some time back, and you can take that time to feel free to reach out to us and find us wherever you need us. If you guys are all good on the poll, I believe we are all set. Go. Let's see if I can get us off of our live stream. Thanks, everybody. Talk soon, and we'll see you on Slack.